Okay, hi fourth block. Today we are going to do assignment 1.8. Just so you know, I am moving the test from Monday to Tuesday because I'm not here. In case you have questions before, I'm going to make Monday a review day. In case you're wondering, I'm not feeling really well. My head's really hurting and my face is kind of droopy. Um, if you were in class, you probably could tell. And so I really feel like I need to go to see a doctor to make sure it's not something, trauma from my car accident. So, but I want to make sure y'all are taken care of. As far as the Nearpod, we're just gonna not do it because I'm not here. I'll just will allow y'all on Monday that if you do a Nearpod, I'm gonna give you 2 stamps. I'm writing the date up on the board so that if you have Gallatin apparel on, you take a selfie like at the beginning of class. Don't do it in the middle or at the last 3 minutes. Don't get your phones out. You go take a selfie, boom, you've got that date, you've got my handwriting. I'll see it on Monday and I'm going to give you that stamp. Okay. So on Monday, if you're wearing Gallatin Monday and today, you just show me that picture and you're going to get the stamp for it. Okay. I don't want anybody to miss out because today's probably a big green and gold day. All right. So today we are going to do a 1.8. And 1.8 is going to be really cool because we've talked a lot about outliers. And right now we've just been kind of guessing on what those outliers are. We've kind of guessed instead of let me see if this makes it better for y'all. Sorry. We've just been kind of guessing. I guess it's going to do this. What an outlier is. Well, today, what I'm going to do, sorry, I lost my train of thought. Today, what we're going to do is I'm going to give you a specific math equation so you can definitively tell me it's an outlier. Okay. It's not going to be a question. It's not going to be subjective. Now we're going to make it very, very black and white. It's an outlier or it's not. Okay. And so we're going to do a lot of this by doing box plots. Now, these are our learning targets. Here's that math rule you've got to do. First, you're going to have to, on your own, StatMedic won't do this, calculate the IQR. IQR is Q3 minus Q1. Then you're going to need to be able to take that number and multiply it by 1.5. This is the math we're going to use to be able to identify and say, it's an outlier. No, it's not. Okay. You're going to be able to have to make box plots and interpret them. StatMedic will make that box plot for you. And then we're going to compare distributions of that quantitative data with box plots. Okay. We're going to be able to look at it. It's going to be really cool because it's going to be LeBron James versus Michael Jordan. Okay. Yeah. I really like the examples in this one. So we're going to start off with LeBron James. Okay. He came on. You guys are going to like this. He was an NBA superstar. He maintained a consistent level of excellence. He has 16 years in his career. He reached the NBA Finals 8 times and he won 3 times. Okay. He is. He's won. When you say LeBron James, you know, oh, basketball. Yeah. He's a basketball player. So here is a dot plot of the data. Now, if you look over here in the far right, sorry, that's not right. That's the left. Right here in that far left, that's a really low number. Okay. I'm going to guess it's probably an outlier, but I don't know for sure. That's my opinion. How can we know if it's a fact or an opinion? This is where the math's going to come in. I'm going to be able to tell you it's an outlier for a fact. Okay. So this is what we're going to do. Okay. First thing I'm going to need you to do is you're going to have to get that IQR. So you're going to need to put all of the data in StatMedic, one sample quantitative. You're going to get that 5-number summary, and IQR is simply Q3 minus Q1. Okay. You're going to do that. You get that IQR. Then what you're going to do from there is you're going to take that number, multiply it by 1.5. You get your new number. So let's just say our IQR is 10. I'm going to do 10 times 1.5 and I get 15. Okay. So my new number now is 15. Now I'm going to go back to Q1 and I'm going to subtract 15 from Q1 and I'm going to add 15 to Q3 because if you look at it, Q1's here, Q3's here. So I'm going to subtract it from my low number and I'm going to add it to my high number. And what's going to happen, I'm going to get a range of numbers. Okay, I'm going to have a lower bound. I'm going to have an upper bound. Anything that falls within this range is not an outlier. But if there's a number that falls below the range, it's an outlier. If it's above the range, it's an outlier. Okay, so let's do this example with LeBron. Identify any outliers. I'm going to statmedic.com/applets. I'm picking quantitative, one sample, and I'm keying in all these numbers. And then I'm hitting begin analysis, and it's going to spit out that summary. And you're going to see on there, you've got min, Q1, median, Q3, max. That's our 5-number summary. Okay. And so we're going to put this in, and you can end up, StatMedic's going to give this for you. It's going to tell you the median is 27.15. Your Q1 is 26.5. This should be a 3 here. And Q3 is 27.95. Now, remember what I told you to do. To find IQR, we do Q3 minus Q1. So 27.95 minus 26.55, and you get the number 1.4. Once I get IQR, what do I want to do? You want to multiply it by 1.5. Okay? And where'd my calculator go? So, come on. Go in my calculator at 1.4 times 1.5, and I get 2.1. So that's my new number. So now I'm going to take that number. I'm going to subtract it from Q1. When I subtract it from Q1, I get 24.45. When I add it to Q3 here, I get 30.05. So this gives me a range. Any numbers in between 24.45 and 30.05, they're not outliers. But if we have a number below 24.45, which we do, 20.9, it's an outlier. So that no longer is my opinion. That's a fact. It's an outlier. Now, 30.05 is our upper bound. If I look up there, ooh, he had a game where he had 31.4. Is it above 30.05? That one's an outlier too. Again, not my opinion anymore. It's a fact. I've proven it. Okay. Now, we want to identify outliers for many reasons. We talked in the past 2 days about how the mean and standard deviation are affected by outliers, but IQR and median is not. So there could be several reasons it's an outlier. What if somebody just wrote it down wrong? What if instead of 30, we accidentally put a 3? Have you ever written a number down wrong? Yeah, people do it all the time. Okay. It could also be maybe we give y'all a survey and we're like, oh, how many hours a night do you spend doing homework? And one of you thinks you're cute and you put down 30,000 hours. Yeah, that's inaccurate. So we'd probably throw that out. It's an outlier. Okay. Outliers can also indicate a remarkable occurrence. Maybe it was like the game of your life and you scored 50 points in a game and you don't repeat it. Okay, you had a stellar night that night. Yeah. The other problem with outliers is they can heavily influence the value of some of our summary statistics. Like, we even said the mean, the range, and the standard deviation are not resistant. So it's gonna change those. It's gonna make them look different than really what it is because we need to remove that special outlier. Okay. So now we could do a dot plot, a stem plot, or a histogram, but sometimes, especially when we're talking about 5-number summary, we want to use a box plot. The box plot is the better one if we're doing that 5-number summary. Okay. So your 5-number summary, this is what's given to, it is given to you in those summary statistics on StatMedic. First number is N, how many pieces of data you had. Second one's mean, standard deviation. Then comes your 5-number summary. 5-number number summary is minimum number, Q1, middle number, Q3, and maximum number. That's your 5-number summary, okay? And a box plot is a representation of that. Now, how am I going to create a box plot? I'm keying it in StatMedic and hitting, ooh, box plot. And then if I need to do a screenshot, that's what I'm uploading. But can you do it by hand? We need to know how to do it by hand. Doesn't mean just because we know how to do it that we're going to do that, okay? Unless you specifically tell me I have to do it by hand. Again, I'm using StatMedic. So the first thing you're going to have to do is find what your 5-number summary is, because you can do that in a calculator, okay? We're going to draw and label the axes. We're going to scale the axes, okay? We're going to scale that axis. We're going to look at, what the lowest number is, what the highest number is, and make sure that it encompasses those. Then we're going to draw a box. So the left side of the box is Q1. The right side of the box is your Q3 number. And then we're going to connect it. We're going to make it a rectangle. So Q1, Q3. You can see that here. Here's Q1. Here's Q3. Okay. Now, the next thing that we're going to do is we're going to mark the median. Here's the median. The median's not necessarily in the middle of the box. Okay. We're going to put it on what that number is. And then we're going to do that formula that I just told you to do. Okay. We're going to do Q3 minus Q1. That gives us our IQR. We're going to multiply that number by 1.5. You can see that right there. We're going to multiply it by 1.5. And then we are going to subtract it from Q1. And we get this lower cutoff right here. Okay. Oops. No. We get this lower cutoff right here. Then I'm going to take that IQR times 1.5 and I'm going to add it to Q3. And I get this upper cutoff number, that range. So if you look in those whiskers, anything that falls within that box and whiskers, they're not outliers. But now when I plot everything, you can see that game where he did 31 point whatever, I can't remember. That's an outlier. He had a stellar game. Incredible game. Like far outside his normal range. The one we had 20.4 or 20.9, I can't remember his rookie season. Again, that was not so good. That was not a good season. I mean, he obviously struggled first year in the NBA and then he was on fire. So that's not within his normal range of his 16 years. So it's an outlier. Okay. And again, now we're not just going, I think it is. You're able to go, I know it is. Yeah. Okay. And I even had a student first block. He goes, why? Why are we doing this? I said, do you really want to know why? Or he goes, why are we multiplying by 1.5? I said, because they told me to. That's the rule. Sure, I'm sure there's a great why as it. I'm sure there's a huge proof. I could care less. You tell me, find the IQR, multiply by 1.5, subtract from Q1, add to Q3. I get my range. Boom, I'm done. Okay. Work smarter, not harder. So if we look here, you should be able to see that, most of the data is going to, or 50% of the data will be within that box. And here we've got most of the data falls within that acceptable range with 2 outliers. Okay. So now here's our example. You got 2 boys. They go around, they want to know, do you always get, the right amount for large French fries? So they go to a bunch of different Burger King restaurants. They order large fry. They went to 14 different ones and then they weighed it. If you go on the Burger King website, it says a large fry should weigh 160 grams. Okay. Should weigh 160 grams. So their thought process is, ooh, am I getting cheated? Am I getting what I paid for? Okay. Because again, I want you to think about this. If it's 160 grams and you can see here, somebody got 170, are we ever going to complain and go, oh, you gave me too much. I need to give it back to you? No. But if I only got, say, 120, we're going to go, this is not a large fry. Like, fill it up. It needs to be a large fry. I paid for a large fry. This is a medium. We're going to complain if we don't get enough. Okay. So we're going to put these numbers into StatMedic. And if you want to play with StatMedic, this is a good time for you to put the numbers in and see if you get the same thing. Okay. So we're going to end up getting that 5-number summary. StatMedic spits it out. Our minimum is 152, max 173. We got Q1, Q2, and our median. Okay. So we are going to turn around. We're going to graph it. Now you're going to do the drop box that says box plot. and it's going to spit it out for you. Okay. So we draw it. Now, here's where you have to do work other than keying numbers. You've got to calculate the IQR. You have to multiply it by 1.5, and then you have to take that number, subtract it from Q1, and add it to Q3. Okay? And so when we do that, you can see here's the formulas. Our low outlier number, our low bound is 152.5. Our upper bound is 180.5. So that means if you get less than 152.5 grams of French fries, that's an outlier. Something happened, something outside the norm. If you get more than 180.5, something happened outside the norm. Maybe the fry cook is your best friend, your BFF, and he threw a whole lot more in there. Or maybe the fry cook is your mortal enemy, and they're like, oh, I'm not giving him enough. Okay? Be outliers. And so if you go back in here in the data, once we draw in our whiskers, you can see there's one value that is an outlier. So one time they went in and only got 152 grams of French fries. Why? Why? Maybe that fry cook didn't like them. Maybe that fry cook was new. Maybe, I don't know, somehow they had slacked and didn't have enough fries and they wanted to get them to you quickly and that's all they had left. But for the most part, you are getting, if you look at this box and whisker plot, you are getting 160 or more. Okay. So you can look at that. Most of the time when they went, they got what the advertised amount was, which is 160 or more. I think one's like 159, really close. And again, we don't ever go back and go, oh, you gave me 3 grams too many, so let me give it back to you. No, you eat it and go, woohoo. Now, let's talk about what are the downsides to a box plot. Okay. A box plot is not going to show if there's any gaps in the data, if there's any clusters where a bunch of them are right here together, or are there peaks in the data like we do in a histogram or a dot plot. Okay. So let me show you an example of that. If we go here, look at this. It's bimodal, means 2 peaks. Modal is peak. We got bimodal. We got a little gap here. Okay. This is Old Faithful, y'all. This is Old Faithful in Yellowstone National Park. It basically just spouts up some water from the earth and it lasts so long. And so when I'm looking at the dot plot, you can see, oh, you're either going to get one that's between 1 minute and 3 minutes or 2.5 minutes, or you're going to get a long eruption that's between 4 and 5 minutes. There doesn't seem to be a whole lot of middle ground in between that, very few that are just 3. Okay. So that's kind of cool information. It's either going to be a short one or it's going to be a little longer. But when we look at that box plot, we don't see that. We don't see that, ooh, there's a dip around 3 minutes. We don't see that at all. Okay. So the box plot hides important information about the shape of this distribution. Okay. So again, each one of them has really, really good uses. This is why I like StatMedic too, because can I toggle between the dot plot, the histogram, and a box plot really easily? Yes. So now here's our example. I told you guys you would like this. Who is the GOAT? Who's the better player of all time? Michael Jordan or LeBron James? And again, you're probably all going to have an opinion on it. Okay. You're going to have an opinion. But can we prove one is better than the other for fact? That's what we're going to do. We're going to prove who's better. So here is the data. Put my glasses on so I can see it. We have the average points scored in each game, per game, each player in the seasons they played. So these are the average points in their season. Okay. So we got LeBron on the top. We got Michael Jordan on the bottom. Okay. I'm going to key this into StatMedic. Okay. And this is going to be where you can do one quantitative variable twice, or you could say 2 quantitative variables. Okay. So you're going to have 2. You're going to have one for James and one for Jordan. Okay. And so here we've got our box plot. And you can see, if we're looking at LeBron, his stuff's a little more compact. Jordan's is a little wider. So we would say Michael Jordan had a greater variability than LeBron James. Michael Jordan, he didn't have any outliers. LeBron does. Okay. If we talk about the shape, kind of got ahead of myself. The shape, again, there's that distribution. LeBron looks like he's a little right skewed because you can see we got that tail out to the right where that whisker is a little longer. If we look at Michael Jordan's, it's just slightly left skewed. The left tail looks just a little bit longer, or the whisker looks just a little bit longer than the right, but not much. Okay. Outliers, LeBron had 2, Michael had 0. Center, okay. If we look at the center, Jordan's average points per game over 50 seasons, then the median came out to 30.1, whereas LeBron's was only 27.5. I mean, that's 3 more points. That's one 3-pointer. Okay. And so if you look, LeBron averaged more points per game than Jordan's median in only 1 season. So he had a couple of those. Now, variability, we already talked about this. Michael Jordan's varied a whole lot more than LeBron's did. Okay. And so when we look at this IQR, 5.7 versus 1.4, when we add all this information in here, yeah, we can definitively say Michael Jordan was better. Michael Jordan's the GOAT. And again, you still may have your opinion. You like LeBron better, but if we're doing statistics, can I prove statistically who is better? Yeah. Okay. So you've got this on here if you need to go and do it with the applet. I don't recommend doing them on a TI-84. I think the graphs on the TI-84 can be sometimes hard to read. Sometimes they turn them. I get them where they're turned right side up with the older calculators. I like the applet much better. Much, much better. Okay, so your I can statements on this, and we discussed this. You're going to use that 1.5 times the IQR rule. That way we can say for a fact it's an outlier, not just, oh, I think it might be. You're going to be able to make that box plot. Again, you should know that it can be made by hand, but again, work harder, not smarter. We're using StatMedic applet. Okay. And then we're going to compare those distributions so that we can say Michael J is a whole lot better than LeBron. Both still great, but statistically, Michael J was better. All right. So that's what I've got. Again, on Monday, we're going to do a review, not a test. Okay. We're going to do a review. We'll test on Tuesday. On Monday, I will do double the value of current events since we don't have it today. And again, I'm writing on the board. I'm going to put a date. You take a selfie in your Gallatin apparel today because I'll erase it on Monday. And that way I will give you that stamp on Monday for your clothes. If you have any questions, you can hit me up on Remind. 1.8 should be keyed for you. And I hope you have a great weekend. Football team beat Hendersonville tonight, and I will see you on Monday.